Hi there, welcome to my channel. In this video, I'm going to discuss about the solution to generate permutations for a given input array. Let's look at the problem description. We are given an array nums of integers and we have to return the all possible permutations. And we can return the answer in any order. So let's take a look at the example 1. So the nums array has 3 elements 1, 2, 3. So there will be 6 permutations for these 3 integers. 1 2 3 1 3 2 2 1 3 2 3 1 3 1 2 3 2 1. Permutations are ordered arrangements of elements, so that's why the 1 2 3 and 3 2 1 are not same, they are different permutation. And in the case of example 2, the input size is 2, so we have 2 permutations. One is 0 1 and the other one is 1 0. So if there are 1 element in the input, there will be only 1. So the constraint for this problem are the length of the array is ranging from 1 to 6 and the value of each element is ranging from -10 to 10, and all the integers of the nums array are unique. Let's look at the approach to solve this problem. So we are given the input array nums which has 3 elements 1 2 3. Okay, so the expected output is 6 permutations. Number of permutations can be found by using the formula n factorial divided by n minus k factorial. In this case, n and k are same, 3. So 3 factorial divided by 0 factorial, which gives 6. So that's why we get 6 permutations. So if you carefully look at this output, the options we have for the first number in the permutation is all the numbers in the input. So if you see here 1 2 3, here 1 2 3, but for the second position, whatever the permutation starts with 1, we can see the possible value for the second number. So only 2 and 3. So except the number whatever added previously, the remaining numbers are the possible numbers for this position. So we already added 1. So the remaining 2 and 3 we can place it as a second number. So once 1 and 2 added, what is the remaining numbers in this input? Only 3 is remaining. So that's why only 3 is added. So we get this permutation. In this case, we already added 1 and 3. What is remaining in the input? 2. So only 2 is added here. And for this permutations begin with number 2. What are all the possible value for the second number? Except 2, whatever remaining in this input. So that is 1 and 3. And what are all the possible values for the third number? Except 1 and 2 in the input set. So in this case only 3 is the possible value here. And for this permutation, except 2 and 3, what is remaining in the input? Only 1. Okay. With this understanding, we can come up with an algorithm. So we start with an empty slice and input array values as the possible values to be in the first position of the permutation. And in the helper function, we iterate over the input number, and after adding each number, we make a recursive call to add a second number, and from there we make another recursive call to add the third number. Okay, and whenever we make a recursive call, we have to exclude the number which was added to the slice. For example, to begin with, we make a recursive call after adding 1 to the slice, and we have to update the possible values by removing 1 from the input. Okay, so to the next level, only 2 and 3 are the possible values for the second position. From the called function, we have to traverse the new input numbers and add each number to the slice and make another recursive call to add the third position number. The call stack depth is equal to the number of elements in the original input numbers array. We can look at the recursive call flow as a tree. Okay, so as I explained earlier, we begin with an empty slate. The input array's value as the possible value to become the first number. So we make a recursive call after adding 1 and update the nums array by removing 1 from the input, the current input. And then we make a recursive call after adding 2 and removing the number 2 from the nums array. We add 3 to the slate and remove the 3 from the nums array. Okay, and from here we add number 2 and remove the number 2 from the inputs nums array, so that the next possible value will be only 3 for this place. So at each layer, the input, all the values in the input numbers are added to the slate, and then that number will be removed from the nums array and then passed down to the next level. So when we reach here, the nums input array length will become 0. So whenever we see an input array length is 0, then we can create a copy of the slate and add it to the result array. Okay, so if you see here, we added 1, 2 and we added 3 here, and then we add this slate to the result array, and here 1, 3 is added and then 2 is added. Here 2, 1 and 3, 2, 3 and 1, and here 3, 1, 2, 3, 2, 1. So that's what I have written here. We can solve this combinatorial enumeration problem using recursion. And first we initialize the slate with empty slice of int, and then the result with the empty slice of int. And then we can call the helper function to process the nums array. And if the nums array is empty, add the slate to the result slice. Otherwise, traverse the elements in the input nums array, and in each iteration add the current element to the slate and create a new slice by excluding the current element from the nums array, and then make a recursive call with the new nums array and the slate. And then after coming back from that recursive call, we have to remove the current element which was added before the call. Okay, so if we repeat that, so whenever we see the input array length is 0, then we create a copy and add it to the result. After we process all the elements, finally we get all the possible permutations. Let's look at the flowchart. Input for this procedure is the nums array and the slate and the result slice. Okay, so first we check whether the nums input array length is 0. If that is true, we create the copy of the slate and add it to the result and then return. Okay, otherwise we initialize the index to 0 and the count to the length of the nums array. Then we enter the for loop, and in each iteration we append the current number to the slate and then remove the current number from the nums array, and then make a recursive call with the new nums array and the slate and the result. After coming back from that recursive call, we remove the current number from the slate. We repeat this until we process all the elements in the nums array. Okay, finally we come out and return. Let's move on to coding. First I initialize the result slice with the empty slice of int, slate with empty slice of int, and then I make a recursive call to permute helper function with num slice and the slate and the result slice. Then finally I return the result slice. Next I am going to write the permute helper function. And this function takes the nums slice and the slate and the result slice. First I check whether the num slice is empty. If it is empty, then I create a copy of the slate slice and add that copy to the result slice, and then I return. Next I process the elements in the num slice. In each iteration I add the current number to the slate. And then I create the new slice. By removing the current number from the num slice. Basically I am creating the next possible values for the next position in the permutation. Then I make a recursive call to the permute helper function with the new nums as the input slice and the slate and the result slice. Then after coming back from that recursive call, I remove the current number from the slate, because we have to restore the slate state to its previous level. Next I am going to run the test cases. All the tests passed. Next I am going to submit this program. Cool, this program is accepted. Next I am going to do the code walkthrough with sample input. In the permute function, first we initialize the result sliced with empty slice of int, and the slate will be initialized with empty slice of int. Okay, that's what we are seeing here. Both are empty, and the input num slice has 3 elements, 1, 2, 3. Okay, then we make a permute helper function. So in the permute helper function, we process each element in the num slice. So in this layer, we fill the first position in the permutation. Okay, so here we add 1, and then we create a new num slice by removing 1 from the current input num slice. So we have 2, 3. Okay, so this will be the input for the next layer. Okay, so only 2 and 3 are the possible value for the permutation, which begins with 1. Okay, when we come here, we check whether the num slice is empty. It is not, so we go ahead and pick up the first number and add it. We create the new num slice by removing the current number from the input. So in this case we remove 2, so only 3 is remaining. So that will be the input for the next layer. Okay, so the slate has 1, 2. When we come here, we check whether the nums slice is empty. It is not, so we pick up the current element and add it here. So the slate has 1, 2, 3. So we create a new num slice by removing the 3 from the input. So after removing 3, the new nums will be empty. Okay, and we make a recursive call, and when we come here, at that time the input slice is empty. So we create a copy of this slate and add it to the result. Okay, so at each layer we make as many number of recursive call as the number of elements in the num slice. Okay, so in this first layer we make 3 recursive call. In the second layer we make 2. The third layer 1. Okay, So in the first layer, the second recursive call includes number 2 as the first number in the permutation. And in the third recursive call in the layer 1, number 3 is added as the first number for the permutations. Okay, so that's why the new num slice is except 3, the remaining numbers are the possible value for the next level, next position in the permutation that starts with number 3. Same here. So this subtree will have all the permutations that begins with 2. Okay, so the next layer positions possible values are except 2, whatever is the remaining number in the input, that is 1, 3. So after completing this, so when the control returns back to the permute function, we have all the permutations stored in the result slice. Next, I'm going to do the time and space complexity analysis for this solution. Time complexity for this solution is order of n times n factorial. Basically, the time complexity is done in terms of copying the generated permutations into the result slice. Okay, so for each permutations there will be order of n times work needs to be done. Basically, we need to copy all the n elements in the slate to the result slice. For n number of elements in the input, the total number of permutations possible is n factorial. Okay, for example, the input of size 3, we get 3 factorial number of permutations, which is 6. Okay, for n number of elements, there will be n factorial possible permutations. Okay, so the totally we need to do this copy operation n factorial times, and in each copy we have to copy n elements, so that's why n times n factorial. Okay, and the space complexity is order of n because we need to store the intermediate results in the slate slice whose size can be maximum the input size, which is n. Okay, in addition to that, we use the stack space internally because we are making a recursive call. So the call stack height also maximum the number of elements in the input. Okay, so that's why the space complexity is order of n. Thanks for watching this video. Have a great day.